The ocean is the lifeblood of our nation, our food, our trade, our connection to the world. But don't be fooled by its calm surface, because this same ocean is also our greatest, most unpredictable adversary. When the Pacific turns, its kinetic energy can reshape entire coastlines in a matter of hours. No warning, no mercy, just a whole new map by morning. For generations, coastal communities lived in fear of that power. But today, that old story has been rewritten. Before construction begins, the entire process starts long before a single seawall section reaches the coastline. Engineers first survey the land, clear vegetation and obstacles from the construction zone, stabilize the ground, and prepare access routes for heavy machinery. Every step is carefully planned to ensure the site is ready for safe and efficient construction. Once the area has been prepared, massive precast wall sections and construction materials are transported from manufacturing facilities to the project site using specialized trucks, barges, or heavy lift equipment. These enormous concrete elements are then carefully lifted into position with high-capacity cranes, where each section is aligned with remarkable precision to create a continuous protective barrier. Before permanent construction continues, engineers put every seawall design through a serious reality check inside massive wave laboratories. Think of it as the ocean giving the design a very strict performance review, except instead of paperwork, it uses powerful waves. These advanced testing facilities generate controlled wave conditions that simulate the forces created by severe storms and tsunamis. Researchers examine how water behaves when it strikes different wall shapes, measuring pressure, turbulence, water velocity, and structural movement with incredible accuracy. Even the smallest adjustment to a wall's angle, surface texture, or geometry can significantly influence how wave energy behaves after impact. The objective is not simply to build a stronger wall, but to build a smarter one. Engineers focus on reducing, redirecting, and dissipating wave energy before it reaches vulnerable areas. Advanced sensors, high-speed cameras, and computer simulations provide detailed information that helps refine every aspect of the design. This scientific approach reduces future maintenance, increases reliability, and ensures the finished seawall performs exactly as intended under extreme conditions. After all, it's much better for a small test model to lose an argument with a giant wave in a laboratory than for a full-sized seawall to lose one in the real world. Japan has installed massive 50-ton automatic steel floodgates at the entrances of many rivers to act as the first line of defense against sudden flooding. These enormous barriers remain open during normal conditions, allowing rivers to flow naturally without interrupting navigation or water movement. However, when water levels begin rising rapidly, an advanced monitoring network immediately goes to work. A combination of water level sensors, flow meters, weather data, and automated control systems continuously analyzes changing river conditions around the clock. The moment dangerous thresholds are detected, hydraulic mechanisms receive the command to activate, and the giant steel gates begin closing within seconds. The speed of this operation is critical because floodwaters can rise dramatically in a very short period. Engineers also build multiple layers of safety into the entire system. Backup power supplies, redundant hydraulic equipment, and continuous diagnostic monitoring allow the floodgates to remain operational even if part of the system experiences technical problems. Regular inspections, lubrication, corrosion protection, and automated testing help maintain long-term reliability in harsh river environments. Rather than reacting after flooding has already reached populated areas, these automated barriers stop dangerous water before it can spread into nearby communities and critical infrastructure. Behind every modern seawall is a highly advanced command center that serves as the brain of the entire coastal defense system. While the walls stand silently along the shoreline, a team of engineers and powerful computer systems work around the clock, constantly monitoring changing ocean conditions. Thousands of sensors installed across hundreds of kilometers of coastline continuously measure tides, wave height, water pressure, current speed, wind conditions, rainfall, and sea level. Every second, enormous amounts of information flow into the control center, creating a real-time picture of what the ocean is doing. It's basically the sea sending thousands of messages every minute, and the command center actually reading every single one. Artificial intelligence processes this massive stream of data far faster than any human could. Advanced prediction models compare current conditions with historical records, weather forecasts, and ocean behavior to identify unusual patterns before they become dangerous. Instead of waiting for waves to arrive, the system calculates how storms are likely to develop, how water levels may change, and which coastal sections could experience the greatest impact. This gives engineers valuable time to prepare long before severe conditions reach the shoreline. Despite the intelligence of modern software, human expertise remains essential. Engineers continuously verify sensor readings, review AI-generated forecasts, and make critical operational decisions based on multiple sources of information. If protective measures become necessary, commands can be issued immediately to activate floodgates, pumping stations, drainage systems, warning networks, and other coastal infrastructure in a carefully coordinated sequence. Modern coastal protection is no longer built on concrete and steel alone. It combines engineering, artificial intelligence, real-time monitoring, automated control systems, and rapid decision-making into one integrated defense network. After all, a seawall may be strong, but even the strongest wall appreciates having a very smart brain keeping an eye on the ocean 24 hours a day. As the sun rises over the coastline, the greatest success isn't something dramatic. It's the complete absence of drama. The sea is calm, the shoreline is intact, and life begins like any other morning. Fishing boats leave the harbor, roads remain open, homes stay dry, and communities carry on with their daily routines. Ironically, when a coastal defense system performs perfectly, it rarely makes the news. No emergency broadcasts, no flooded streets, no last-minute evacuations, just another peaceful day. In coastal engineering, that's about as close as you get to a standing ovation. The storm has come and gone, but the seawall remains exactly where it was designed to be, absorbing immense forces while protecting everything behind it. Its success isn't measured by how impressive it looks, but by how little people have to think about it. Every sensor, floodgate, drainage system, and reinforced barrier has quietly done its job, allowing normal life to continue without interruption. That has always been the true purpose of coastal defense, not creating headlines, but preventing them. Waves will continue to rise, storms will continue to form, and tides will never stop following the laws of nature. What has changed is humanity's ability to prepare intelligently for those challenges. Through innovation, constant monitoring, and smarter engineering, coastal communities have transformed vulnerability into resilience. A strong coastline is more than a physical barrier. It is a promise that future generations can live, work, and grow with greater confidence. Because in the end, the greatest engineering achievement isn't defeating the ocean, it's making sure people hardly notice the battle ever happened.